Hi everyone, my name is Sam Noyce and I'll be presenting on my scanning research and specifically enhanced detection capabilities using Nmap. So I'll be talking about ways to extend Nmap to better detect and classify custom or less common services and protocols and ways to improve the fingerprinting capabilities of Nmap. So what is Nmap? So Nmap is an open source tool for network discovery and security auditing. It was designed to scan and map large enterprise networks efficiently and used to identify hosts, services, operating system versions, firewalls, and more using IP packets. It's also a valuable tool for offensive security professionals for vulnerability discovery and attack planning. So on the right here is an example of a simple Nmap scan. So Nmap scans include a list of targets with information based on the scan parameters inputted by the user. On the example on the right here shows a list of discovered ports, protocols, services, and their states. The states of the ports could include open if they're listening, filtered if they're blocked by a firewall, closed if there's no listener on the port, or unfiltered if there's a response but it's unclear what the response is on the port. And scan results also reveal operating system types, device types, and MAC addresses. So one way to extend the capabilities of Nmap is using the Nmap scripting engine. So the Nmap scripting engine extends Nmap by automating tasks like service detection, reconnaissance, and vulnerability scanning. The scripts for the Nmap scripting engine are written in the Lua programming language to provide deeper and more intelligent network analysis. And it's used by offensive security professionals to detect and classify custom services and protocols. The Nmap scripting engine scripts are organized into categories based on their functionality to make it easier to find and run scripts for specific tasks. And these categories can include the auth category for scripts that test authentication mechanisms and credential-based access. There's a brute category for scripts that perform brute force attacks on authentication systems. A malware category for scripts detecting malware-related activity. And a version category for scripts that determine application version running on the target hosts. And then there's a long list of other categories with scripts categorized based on their functionality. So on the right here is an example of a Nmap scripting engine script. So the Nmap scripting engine scripts are written in the Lua programming language and follow a structured format with the head, rule, and action sections. This example on the right uses the built-in Nmap modules such as HTTP and short port to target HTTP services and retrieve headers. Many open source Nmap scripting engine scripts are available for detecting vulnerabilities, brute force logins, and discovering malware, and then a long list of other functionalities, all organized into different categories. And these Nmap scripting engine scripts enable advanced security testing and allow for the creation of custom detection tools for specific needs. So now a little bit about the Nmap fingerprinting capabilities. So Nmap uses operating system fingerprinting to identify the type and version of the operating systems on the host that it's scanning. Knowing the operating system helps detect unauthorized devices and assess potential vulnerabilities. And operating system detection works by sending packets to a target, analyzing responses, and matching signatures against a database of known operating system signatures. And the Nmap's fingerprint database includes community contributed data collected since 1998. So how can this fingerprinting capability be improved? So currently the Nmap database contains over 2,600 operating system fingerprints with details such as operating system description, the vendor, generation, and device type. And one way to improve it is just through community contributions. So community members can submit new fingerprints to improve the database and enhance operating system detection accuracy. And a more modern method is using machine learning algorithms and artificial intelligence. So machine learning and AI offer modern methods to improve Nmap's operating system fingerprinting capabilities. In a paper that I read for this research project, with the link that's on the bottom of the slide here, titled Applying Artificial Intelligence to Operating System Fingerprinting, found that the random forest algorithm achieves over 96% accuracy with Nmap data and approaches 97% after optimizing the algorithm. And this is also with limited computational resources, which means that with more advanced computer power, that the accuracy of these algorithms could just improve from the 96 97% mark to be even more accurate than what was shown in this research paper. So that is a little bit about the different ways to extend Nmap for better detection and scanning capabilities. Thank you all for listening, and let me